Whee! I'm having so much fun. How about you? All right, we just talked about data integrity. How does a company ensure that you cannot go in and change and modify things after the fact? And this is the most common violation that companies normally do. So this is where our discussion stopped, and I told you that in the next video we're going to talk about document roles. Oh God, oh my God. Look at all of these. Look at all of them. All right, so let's imagine I'm working in a lab facility, and in this lab they are regulated, and they're going to look for documentation policies, GDPs, good documentation practices. These are some of the big documentation practices that need to be followed as I'm in the lab and as I'm working. Number one, let's start up here at the top. Am I working in real time? Am I documenting things in real time? I should be writing as I go. I cannot take a document and write hours later or 30 minutes later on something that I did just a little bit ago. So as I'm doing a task, I better be writing it down. So real time, very important. Number two, I'm going to have to use permanent ink in order to document those things on a piece of paper or in a lab journal or a notebook. Permanent ink is going to typically include black and or blue ink, no other colors. Actually, some people are even stricter, and they might say black only. So this is going to be made up with the company. The company will let you know what their policy is. But folks, absolutely no pencils. Absolutely no pens that can get erased. It's got to be permanent ink. And if you've got an eraser, that's not permanent. Number three, can you read it? So unlike my lecture notes, can you read what you are writing on the laboratory notebook or in the laboratory document? I hope so. If not, you need to improve and work on that a little bit more. Number four, we're going to have to double check the calculations. There's probably times I'm going to do calculations in a laboratory on a laboratory notebook sheet or in a laboratory notebook. I want to double check those calculations as I do them. And again, the calculations should be somewhat real time. So as I'm generating data, I'm putting the data points in. And when I get enough data in order to complete a calculation, then I'm going to do the calculation as quickly as possible and double check to make sure that I didn't mess up as far as the calculation goes. And the reason is because this calculation can actually affect other things that are going to happen a little bit later in the method or in the standard operating procedure. Number five, as far as lab documents go, laboratory notebooks, I need to sign and date this, folks. I know it seems like weird and odd, and it's the same thing over and over and over and over, but every single page needs to be signed, and every single page needs to be dated. That's just the way that it is. That's what we've got to do, and that means that your signature approves all of the information on the document, and the date is for tracking purposes because that is going to be a requirement for GDPs. Number six, follow the date and time format. So some people will do month, day, year, some do not. As far as the time format goes, some people are okay with AM and PM, and some are not. They are military time. So whatever your company's policy is, they will let you know, and you want to make sure that you follow that template or that model. Number seven, you want to make sure documentation purposes that the manufacturer and the lot numbers are recorded from the labels. So what company made the reagent that you're using and what lot number was stamped on the label. Those are very important things that we have to keep track of, because if something messes up, it could be because of this. Maybe a lot has went bad, or maybe they didn't make the lot the right way and we're using the wrong stuff, but we're assuming that it's proper, and we should not be doing that. So recording manufacturer and lot numbers down, very important. Number 8, for documentation purposes, no ditto marks. You can't use the little quotes to say, hey, well, I did the same thing all over. No, you can't do that. You have to rewrite things. You have to write down the new measurements, the new steps, because chances are you didn't do those steps exactly the same way anyway. And even if you did them exactly the same way, you need to document that you did them exactly the same way. So that forces us to write down all of those steps all over again if I've got to redo or repeat things. Number 9, don't overwrite the errors. We'll talk about this in a minute, but errors should be seen, and people should be able to see those mistakes. You cannot completely cross them out. You cannot erase them. They have to be, once they go into the document or into the notebook, it is a permanent record, and it has to stay there. You can correct them, but there's a proper way to correct them. Number 10, no correction fluid and no erasers. So in other words, no whiteout should be found in a laboratory setting. Absolutely not. And no erasers should be found in a laboratory setting. You cannot use that for documentation purposes. You cannot erase mistakes. You cannot white out mistakes. You have to keep that mistake in there. You can correct them, but you're going to have to tell us why. Number 11, you cannot backdate. Documentation purposes, backdating is a problem. Backdating means that you did something not in real time, and I want you to refer to rule number 1. So as you write things down, and as you record things, and as you print off things, when you sign it, you better date it for that day. You cannot backdate, meaning, oh my God, I forgot to sign and date something from 1 week ago. Well, nobody will ever know. I'll go in and I'll sign and date it from 1 week ago, and we'll be okay. Don't do that. Don't be that person. Somebody's going to find out. Number 12, there should always be a second reviewer for the most part, and this is something that confirms you've measured out something, confirms that you observed something, confirms that you did something the proper way. It is a second set of eyeballs, and very often this is good documentation practice, so that way we're not just taking your word for it, we're taking someone else's word for it too, and that person can be your cellmate when you go to prison because you've lied on a document. Number 13, no blanks in a laboratory document or a laboratory notebook. So if you get an area and that area is not going to be used, you want to write an NA, and you want to completely cross out or X out that entire area, so that way it cannot be used at a later date. We are telling a reviewer, absolutely not. No more is going to get recorded on this document, and I am crossing out all the area that I can write things in to help make sure the integrity is there. No one added stuff after the fact. Number 14, if you make mistakes, that is perfectly okay. No one says that you can't, but if you do make mistakes, it's got to be logged. It's got to be documented. What this means is that if I make a mistake and I spell my name wrong, whoa, I can't erase it. Erasing, violation of number 10. So I'm going to cross out that word. That's a strike through. And that tells a person this is a mistake. Number 15, it says detail why mistakes are corrected. So over here to the side, I'm going to have to write spelling error. Maybe that's why I decided to cross it out. I got to tell somebody why though, which means more writing, more documentation. Next up is 16. And it says, make sure you sign and date that correction. All right, so I'm going to sign off on it, and then I'm going to date it to let people know when that mistake was found, when that mistake was discovered. It was discovered in real time. I made the correction immediately, and I signed it. I gave an explanation why, and I dated it. Number 17, if you find yourself making common mistakes all the time, you are more than welcome to footnote. Typically, companies are okay with this, and a footnote is more like a code. So instead of writing spelling error, I can just maybe write 1 and circle it. And that 1 at the very bottom of that page, I'll draw 1, and it'll be spelling error. And that way, whenever I have a spelling error, then I can just simply write a 1 near that mistake, and I don't have to write spelling error, 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 over and over and over and over and over. Number 18, no cutting, please. No scissors should be found in a laboratory setting. It is the whole thing or nothing at all, which means that if I print off reports and they're 8x11s, I better put the entire 8x11 in the lab notebook or on the lab document in some form or fashion. A lot of times this requires folding, taping, securing, stapling, whatever the case is. But a permanent attachment has to go in, and it needs to be representative of the entire sheet of paper. Whatever that piece of paper is, size-wise, from that instrument or from that printer, no scissors. Stay away from them. No erasers, no whiteout, no scissors. This is not scrapbook class. This is a journal documentation in a laboratory environment, and no scissors or pretty little stickers or pretty pen colors, none of that can be found in a lab. Number 19, no hole punch. So you cannot have laboratory notebooks that are 3-ring binders. And the reason is because you can take out pages and insert pages. So you can add things and modify things very easily in a 3-ring binder. So stay away from them. They cannot be used. The hole punch spine bound is going to be approved. Not even a 1-subject notebook, folks. 1-subject notebook has a spiral binding that you are using to flip page after page after page. That spiral binding can be unspiraled out of all of the papers. And you can take pages out and put pages in, and no one would be the wiser. And then you can spiral bound it back. You cannot use anything with spiral binding or ring binding. It's got to be a composition notebook. It has to be glued. It has to be permanently in there. You cannot rip things out. You cannot put things in. That's the way that we've got to handle the laboratory documentation purposes. Number 20, 1 experiment per page. If I'm writing in a notebook, if I'm writing in a journal, that 1 experiment needs to go on to a page and be representative of that page only. If I'm doing 2 or 3 things at one time, only 1 thing can go onto that document sheet. All the other things have to have their own separate pages or their own pages within my laboratory notebook. I cannot mix and juggle 15 things or even 2 things on the same page of paper. 21, you want to make sure that your name and your date and the title is at the top of each page in case they do get lost. That way we know who they go to, what you were doing in the documentation part of the process, and the time and date that you were doing them as well. They can go to the proper owner, and we can keep up with them if they do get lost. And finally, number 22, don't forget observations. We get so wrapped up in the data, we get so wrapped up in writing down the steps that very often it's easy to forget observations. And if I'm making observations in the laboratory procedure, I'm looking at what color things are turning. I'm looking at if bubbles are getting generated. I'm looking at if this thing gets hot or if this thing gets cold. You know, what is happening observational wise? That needs to be documented as well. And a lot of people forget that because it's such an easy thing to forget when you start focusing on all of these other things. When we talk about mistakes, this is kind of an example of what we're after or what we're looking for. So if I make a mistake, notice here, circled area, they have did a strike through with 100.01 gram. And up above it, they wrote 100.00 gram. And then down here at the bottom, they've signed it, which is their initial, and then they've dated it. So that mistake is legible. I can see what was there before. I can also see that it was a mistake because somebody crossed it out, and I can see that they wrote in a new number. Somewhere on this, they're going to have to write why they crossed it out. Now, I'm assuming that it's because it's the wrong number, but you have to be very clear about it. So there should still be a justification in place in some form or fashion. Next up, just to change the pace a little bit, here's CFR Title 40, Part 160. It's really the EPA, but the EPA rule and the FDA rule is about the same. This just comes from the EPA just to get out of the FDA. Section 160.3, definitions, raw data. Raw data means any laboratory worksheets, records, memoranda, notes, or exact copies that are result of the original observations and activities of a study and are necessary for the reconstruction and evaluation of the report of that study. So very often I'm asked a question, and the question is, what about scrap paper? I want my notebook to be so pretty. I want my notebook to be no mistakes, and I want it all organized. It's just not going to happen. It's not meant to happen that way. If it is too pretty, if it's too organized, the auditor will begin to question it because they know that no one is that perfect. So very often I get the question, well, if I use scrap paper, can I write things on the scrap paper and then use the scrap paper and record into my lab notebook or on the laboratory document the things that I did and then just throw the scrap paper away? No, you can't. Absolutely not. And the reason is because that scrap paper, ladies and gentlemen, that is considered raw data because you recorded it in real time with permanent ink and you made a document that has to be kept. So that scrap paper is considered raw data. And that scrap paper is not scrap. It is paper, and all of it needs to be saved and kept. You cannot write things on a sheet of paper, transfer it into a proper document or notebook, and then throw that scrap paper away because there is no such thing as scrap paper. As far as raw data goes, raw data can be a number of things, ladies and gentlemen. There's tons of things that can be raw data. Logbooks, again, for equipment use, equipment repair. Laboratory notebooks is raw data. Field forms or field reports or live data, raw data. Any type of form, chain of custody, sample, chemical receipts, all of those are raw data. Training reports, computer printouts, recorded data from the instruments, everything has to be kept because everything at its basics, as it's getting generated, is called raw data. And that's something that we have to keep track of. It's something that we have to file. It's something that is very important for a laboratory and data integrity. So, nothing off the tables. Everything has got to be kept. All right, so in the next video, we're going to focus on a few different words. And some of that word is standardize, and some is calibrate, and some is verify. So 3 terms. I just want to make sure now's the time to make sure that I distinguish between all 3 of those terms. What do they actually mean, and how does it relate to us when it concerns laboratory or manufacturing type of work? So that's something that's very important, and that's what we'll talk about next in the upcoming video.